Hi everyone, my name is Fiona Price and today's date is July 18th, 2024. So let's dive into finding the center of mass for Region 1 for Project 2. I'm going to share my screen. And you can see in the bottom, this is today's date. And I'm also going to pull up, so this is the region that we want to find the center of mass for. So you've got a semicircle with a radius of 35 feet, and then another semicircle that's carved out with a radius of 25 feet. So let's just start with one semicircle at a time. Let's find the center of mass for the outer one, the bigger one with the radius of 35 feet. So to find the center of mass, we're going to take the moment divided by the total mass. However, we don't really need to divide it by the mass because both of these have density in front, and that would cancel out. So instead of dividing it by the mass, we're really just going to divide it by the area, so we don't have to deal with our big, complicated density number, which we found in an earlier problem. So really, I'm looking at two different areas here. So at the top, as stated in our textbook, to find the moment, you do f of x squared over 2. Now, with this semicircle, we know that the radius is 35. So we're going to set up our integral so that we're evaluating it from 35 to negative 35. So we're going from this end to this end, right? And then inside, we're going to do y squared over 2. Now I can pull out this 1/2 so that we don't have this inside the integral because it's just easier to deal with the constants outside of them and keep the actual integrand as clean as possible. In the bottom, we're going to have 1/2 35 squared times pi, so pi r squared, but remember that this is a semicircle, so we only want half of that area. So this is what it looks like set up. But now remember, for a circle, that x squared plus y squared equals r squared. So we know r squared. We know it's 35 squared because that's our radius. So now we can use that to actually solve for y. And so then we'll have it match our integral. So now in this step, in the next step, I'm not looking at the area on the bottom. That's easy, we've done that, and we'll come back to it. So let's just look at evaluating the integral. So I've got 1/2, and we're evaluating from negative 35 to 35. But instead of y squared, now what I've done, because I need this in terms of x, is I've done 35 squared minus x squared. And then we're going to take the derivative of that. So now, to evaluate this, we're going to do 1/2 times 35 squared x minus x cubed over 3, because this all is the antiderivative of this. And then we're evaluating that from 35 to negative 35. And then this step is just going to be algebra. It's kind of messy. What you could do to make this a little easier for yourself is instead of doing 35 to negative 35, you can do 35 to 0 and then double it all because you know that both halves are equivalent. I did not do that here, but essentially I found this just with simple algebra. It came out to this, but then in this last step, I pulled back our area. So 35 squared times pi divided by 2. Remember, 35 is our radius, and that came out to 1,225 pi over 2. When you calculate all of this, you get about 14.855. But that's just the outer semicircle, right? So now we need to do the inner semicircle. So that was our center of mass for the outer. Let's look at center of mass for the inner. And essentially what I've done here is the exact same thing, but now it's with a different radius. It's with 25. So anytime that there was a 35, now there's a 25. So we're evaluating the integral, 25, negative 25. Again, like I said, you could do 25 to 0 and then have a 2 outside of the integral, and that would be the same thing. We're doing the y squared again, but this time y squared equals 25 squared minus x squared because this is our r squared. Yeah, and we're evaluating it the same way. 25 squared x minus x cubed over 3 this time. And plug in the numbers, and this will come out to about 10.610. Okay, so we've got our two centers of mass. Now what do we do? So if you look at this little graph I made down here, it's not super clear, but basically I've shown you where the center of mass is for the outer. So this is 14.855. And it's also important to note that we're not even looking at the x-coordinate because it's symmetrical about the y-axis, right? So we know that the center of mass is going to be along the y-axis because it's symmetrical about that. So the x-coordinate has to be 0. So I'm focusing purely on the y-coordinate right now. So returning to this, our y-coordinate here is 14.855, so 14.9-ish. And then for the inner semicircle, it's 10.6-ish. And that makes sense, right? Because the inner one is smaller, so this is going to be closer to 0. Now, if we just subtracted 10.6 from the 14.9, that would be way too low. That would be down here. And that's not right. So what we're doing is we are subtracting the 10.6 from the 14.855. So those, again, were our two centers of mass. But then we have to add back this 14.9. And I think it's a little more clear visually. So this middle one is our y outer, and we're subtracting the inner from that. And then we're adding back 14.9. And that should be our center of mass for the whole area. Thank you.